Dear students, today let us solve some problems related to Coimbu University BSc 3rd semester Geometrical Optics Session 7. Myself, Dr. Niranjana A.R., Assistant Professor of Physics. This session is dedicated to problem solving. First problem. Calculate the focal lengths of the crown and flint glass lenses that form an achromatic doublet of a focal length 50 cm when placed in contact. The refractive indices for the C and F lines are given below. Crown mu C is equal to 1.515. Mu F is equal to 1.523. Flint mu C is equal to 1.644. Mu F is equal to 1.664. Solution. Omega 1 is equal to 1.523 minus 1.515 whole divided by 1.523 plus 1.515 by 2 minus 1, which turns out to be equal to 0.008 by 0.519, which is equal to 8 divided by 519. Omega 2 is equal to 1.664 minus 1.644 whole divided by 1.664 plus 1.644 by 2 minus 1, which is equal to 0.020 by 0.654, which is equal to 10 divided by 327. For achromatization, the condition is omega 1 by f1 plus omega 2 by f2 is equal to 0, or omega 1 by f1 is equal to minus omega 2 by f2. Therefore, 1 by f2 is equal to omega 1 by omega 2 f1, which is equal to 8 into 327 divided by 519 into 10 f1. 1 by capital F is equal to 1 by f1 plus 1 by f2, which is equal to 1 by 50. Therefore, 1 by f1 minus of 8 into 327 whole divided by 512 into 10f, which is equal to 1 by 50, or 1 by f1 into 1 minus 8 into 327 by 519 into 10, which is equal to 1 by 50. F1 is equal to 24.79 centimeter, which is of ground glass convex lens. From equation 1, F2 is equal to minus 519 into 10 into 24.79 divided by 8 into 327, which is equal to minus 49.19 centimeter, which is of flint glass concave lens. Going to the next problem. It is desired to make a converging achromatic lens of mean focal length 30 cm by using two lenses of materials A and B. If the dispersive powers of A and B are in the ratio 1:2, find the focal length of each lens. Solution: given that omega 1 by omega 2 is equal to half, we know that omega 1 by f1 plus omega 2 by f2 is equal to 0. Therefore, 1 by f2 is equal to minus of omega 1 by omega 2 f1. Therefore, 1 by f2 is equal to 1 by 2 f1 with a minus sign. Call that equation 1. 1 by f is equal to 1 by f1 plus 1 by f2 is equal to 1 by 30, or 1 by f1 minus 1 by 2 f1 is equal to 1 by 30. Therefore, f1 is equal to 15 cm. From the equation 1, f2 is equal to minus 2 f1, which is equal to minus 2 into 15 cm, which is equal to minus 30 cm. Coming to the third problem. Two lenses of focal lengths 8 cm and 4 cm are placed at a certain distance apart. Calculate the distance between the lenses if they form an achromatic combination. Solution: here given that f1 is equal to 8 cm, f2 is equal to 4 cm, x is equal to how much? We know that x is equal to f1 plus f2 by 2. Therefore, x is equal to 8 cm plus 4 cm by 2, which is equal to 6 cm. Coming to the fourth problem for this session. Two thin lenses of focal lengths f1 and f2 separated by a distance have an equivalent focal length 50 cm. The combination satisfies the conditions for no chromatic aberration and minimum spherical aberration. Find the values of f1, f2 and d. Assume that both the lenses are of the same material. Solution: we know that 1 by f is equal to 1 by f1 plus 1 by f2 minus x by f1 f2, which is equal to f1 plus f2 minus x by f1 f2. Call that equation 1. Here f is equal to 50 cm and for no chromatic aberration x is equal to f1 plus f2 by 2. For minimum spherical aberration x is equal to f1 minus f2. Call that equation 2. From 2 and 3 we get f1 is equal to 3x by 2 and f2 is equal to x by 2. Substituting these values of f1 and f2 in equation 1, we obtain 1 by 50 cm is equal to 3x by 2 plus x by 2 minus x by 3x by 2 into x by 2. Therefore, x is equal to 200 by 3 cm, which is equal to 66.67 cm. If we truncate to nearest decimal digits, Therefore, f1 is equal to 3x by 2, which is equal to 100 centimeter, and f2 is equal to x by 2, which is equal to 33.33 centimeter. Coming to the fifth problem, an object of a telescope is an achromat of focal length 90 centimeter. The magnitudes of the dispersive powers of the two lenses are 0.024 and 0.036. Calculate their focal lengths. Solution. Here, given that omega 1 is equal to 0.024, omega 2 is equal to 0.036, and f is equal to 90 centimeter. Omega 1 by f1 plus omega 2 by f2 is equal to 0. Therefore, 1 by f2 is equal to minus omega 1 by omega 2 f1, which is equal to 1 by f2, which is equal to minus 0.024 by 0.036 f1, which is equal to minus 2 by 3 f1. Also, 1 by f is equal to 1 by f1 plus 1 by f2, which is equal to 1 by 90 centimeter, or 1 by f1 minus 2 by 3 f1, which is equal to 1 by 90 centimeter, or f1 is equal to 30 centimeter. Therefore, f2 is equal to minus 3 by 2 f1, which is equal to minus 45 centimeter. The object glass is made of a combination of convex lens of focal length 30 centimeter and a concave lens of focal length 45 centimeter. Next problem. Two thin convex lenses of focal length 20 centimeter and 5 centimeter placed 10 centimeter apart. Calculate the positions of the principal positions of this combination. Solution. Consider 1 by f is equal to 1 by f1 plus 1 by f2 minus b by f1 f2. f1 is equal to 20 centimeter, f2 is equal to 5 centimeter, and d is equal to 10 centimeter. Putting these values in above equation, we get f is equal to 6.67 centimeter. Then alpha is equal to plus df by f2, which is equal to 10 into 6.67 all divided by 5, which is equal to 13.33 centimeter. Beta is given by beta is equal to minus df by f1, which is equal to minus 10 into 6.67 by 20, which is equal to minus 3.33 centimeters. If we draw the diagram, it looks like this. Carefully observe the diagram. P1 and P2 are positions of the principal points as shown in the above diagram. References: Optics by Ajoy K. Ghatak, 6th edition, TMH Publishers. Second reference: Textbook of Optics, revised edition, for BSc classes as per UGC model syllabus. Authors N. Subramaniam, Brijlal and M. N. Avadanulu. Sultan Chand Publishers. Some internet link is equal to third one reference is given http www.admissionglobal.com test prefix page 4.asx. Thank you, one and all.